This is Calculus 12, Chapter 2.2. We're going to be looking at limits, and specifically, this is the precise definition of a limit. This definition is important for proving theorems. If you're taking the easier version of calculus, you won't need to know this, so this video is optional. We have to interpret this precise definition, and we have C and L. They have to be real numbers. It can't be infinity. We're saying the function has a limit, L, as x approaches C, if for any positive number delta and for all x. We have 0 is less than the absolute value of x minus c is less than delta when the absolute value of f of x minus L is less than epsilon. So what does this mean? It means x needs to be close to c, and we have the absolute value so that it's on either side of c. And same thing for f of x and L. It has to be on either side of L. And when we have this case, we can write the limit as x approaches c, f of x equals L. So here's an example. Prove that the limit as x approaches -2, 2x plus 1 equals -3. So our job is to find this delta when we have this situation. So this is just f of x minus -3, so that's plus 3. So we need to simplify this. We need to simplify this, and we write that as 2x plus 4 is less than epsilon. We factor so that it looks like this. So we have 2 times the absolute value of x plus 2 is less than epsilon. And this is actually this. We just have to change it to x minus -2. We bring the 2 over to the other side, so it's epsilon divided by 2. This tells us that delta is epsilon divided by 2. Now we can do our proof using the definition. Let epsilon be greater than 0. Then we have this, f of x minus L. We simplify it, and this doesn't need to be there. We factor this, and now it looks like this whole statement. We multiply both sides by 2, and this side stays the same. And then we get 2, absolute value of x plus 2 is less than 2 times epsilon over 2, because that's our delta. And we get less than epsilon, which is what we have here. And then we just restate it. So if we take delta equals epsilon over 2, and 0 is less than the absolute value of x minus -2 is less than delta. Remember, this is our x minus c. Then we have limit x approaches -2 of 2x plus 1 equals -3. And that is the precise definition of a limit. And again, we use this to prove the theorems that we're going to be using later on. So what does this look like graphically? So here we have our origin. Here we have our point. If we look at our point, this is C, this is L. And if we take our epsilon, We can see that this is above and below, so that's why we do the absolute value of f of x minus L. And if we take this up, we can see this is delta and this is delta. And again, we can see why this is absolute value because we have the negative side and the positive side. And using our example, you can see that this delta is approximately half of epsilon, and this delta is half of epsilon. And that's all we're trying to do. We're trying to find the delta that will give us the precise epsilon. And again, this is only required in the harder calculus courses. And that completes this lesson.